Okay, hello guys. Am I audible? Am I audible to everyone behind? Cool. So, welcome everyone. Welcome to the very first event by AI Society this semester. Before we begin with the guest lecture, which I'm pretty sure you all are really excited about, I would like to call upon Professor Vivek Gupta. He's one of the new faculties at Sky, and he has some wonderful, wonderful research opportunities for volunteership and much more. So, over to you, Professor. After this quick announcement, we'll proceed with the guest speaker.
Thanks for this. I came unintended. Thanks to them for allowing me to speak for 2 minutes. And sorry about the speaker. So hi everyone. I'm Vivek. I'm a new assistant professor at Sky. I'm building my own research lab called Coral, which is complex data reasoning and analysis lab. So this is a brief education history about me. I'm a graduate from Kanpur, IT Kanpur. I worked at MSR for 2 years, and I did my PhD in Salt Lake City. If you have been into Utah and all, like it's a wonderful place. I spent around 1.5 years at Penn doing my postdoc research. So these are some of the topics I work on. So I'm working on complex data types, which include tables, charts, maps, and also using large language models. So I'm pretty sure, raise hand if you have used ChatGPT or something similar. Yeah, so most of you have done that. So I try to understand the mechanism, how they reasons, as well as try to use them in interesting applications, which include making them reason on complex charts, types, tables, and all. So these are some of the problem I'm working on, like understanding LLM reasoning, uh, application of them in like very high precision settings, for example, finance, medical, where you can't make a mistakes and all. So you want to build a trustworthy machine learning models and all. And then also like applications in other fields like geographic, like maps and all. So how do you understand on some of those? So, sorry. So if you are interested, so I'm looking for undergrad, masters, and even if you are a PhD student who haven't decided on the advisor and all, you can check this out. And you can check my profile also, Vivek Gupta at Sky. So this form, you can fill it up and I can do. And briefly, very quick summary of what I do is like some of the work I do is like working on like tables like these and how do you reason on them. So earlier I call it stir because it was just table and all. But now I have gone beyond that and like we are doing something more on interesting on charts, like these data also, like for example, like charts, maps, flow charts and others. So I won't take much of the time. So if you're interested, again, you can fill up this form and contact me. You can also email me, but it's better you first fill up the form. Otherwise, I will ask you to fill up that first. Okay. Thank you. Thanks for this.
Okay, thank you so much, Professor. Also, guys, this QR code, form link, and all the details about this volunteer program we'll be sharing in our Discord server as well. So, highly, highly recommend join our Discord server, follow our Instagram for all these kinds of updates. We had the link up before this session began, and we'll again have the Discord link up at the end of the session. Do follow that. Now, I would like to hand it over to Krisha Vagela, our president, to talk about the club's vision, since this is our first event this semester, and also introduce our guest speaker and begin the event. So over to you, Krisha. Also, guys, by the way, it is her birthday today. So let's wish her 3, 2, 1. Happy birthday, Krisha. So over to you.
Hi guys, can you hear me? Okay. So thank you so much for coming and taking your time to, come to our event. So basically our vision for AI Society is not only we're gonna have workshops for NLP and ML based workshops, but we're also gonna have like guest speaker events, we're gonna have A mountain hikes, we're gonna have game nights, and we're at the end we're gonna have hackathons. So if you attend our like ML and NLP labs, you can form your groups there, like meet like-minded people, as you can see in the room, and like form a team too for the hackathon. So yeah. And now I'd like to introduce our guest speaker, Sagarika. So you want to introduce yourself?
Yeah, sure. Should I? Okay, there you go. Guys, give it a round of applause.
the controls here, so forward and backward, and your notes should be up here.
Okay, these two, right? Okay, hi all, can you hear me? Okay, great. So yeah, I'm Sagarika. Sorry, I think it's okay. So yeah, I'm Sagarika. I am a analytics engineer at Intel, and I'll be chatting with you guys a little bit more on the AI industry perspective, some of the things that we do. I think it's
Yeah, we can hear you.
okay, okay, as long as that's okay.
Yeah, no.
Yeah. So yeah, that's what I'll be talking about today. Yeah, it's the same thing. Yeah, so as I mentioned, I'm an analytics engineer at Intel, and specifically, I work a lot in the supply chain domain. So a lot of my work revolves around things like the semiconductor manufacturing process, looking at how we can apply AI to make things better, to make things more efficient. Some things that I've worked on are in the, for example, fab construction space. So, a lot of our fab is on procurement, long lead inventories. How do we optimize our procurement strategies, things like that? A lot more on the supply chain focus. Other things that I've worked on are things like wafer yield analyses. Okay, we have defects, trying to figure out why. Some more of the things that I've worked on are around ecosystem risk sensing, right? So everyone knows, COVID happened. That was a big impact to all supply chains all around the world, and very much to Intel as well. So not only looking at, okay, what's my next supply chain risk for this next week? What's the supply chain risks coming up in the next month, in the next year? Things like that. So I think if you're here, you probably have an idea of what AI is. But given the audience, I thought it would be good to just start off with the basics, right? In case so we're all on the same page. So right, the question is, what is actually AI, right? What is artificial intelligence? So if we're just talking about machine learning or artificial intelligence, it's really how can we design machines, right? That can learn, that can infer, that can reason just like a human. And the domain itself has been around for, a very long time, ever since even back to the 1980s, for example, right? But it's just now that we have things like more compute power, we have things like GPUs, right? That we're able to take this a lot further than we were able to before. So, that's why in the 2010s, right, that's when machine learning started. I mean, it was there, but it started to become a lot more bigger. So things like, unsupervised, supervised learning techniques. This is where you get, your regression, your classification, your clustering, all of those became, it was a boom in machine learning, right? And then right after that, we got the boom in deep learning, right? And that's all about yeah, this is, yeah. Hello, can you hear me? Okay, I think it's actually, hello? Okay, that's fine. If you can hear me, it's okay. Yeah, so deep learning, right? And that's all about things like neural networks and, how can we do things like model how the brain works in the actual machine. So and then finally, we have generative AI, right? And that's another branch of deep learning where instead now we're building these huge, huge models where we are training billions and billions of parameters. We're training on huge terabytes of data, and we're creating these models that can be used for general purpose solutions. And yeah, that's really where the fun and exciting stuff has been happening in the last couple of months and years, really. So, and that's right, ChatGPT today. So I'm sure a lot of you use that, and not for your homework, right? So yeah. So I think we baselined a lot on. Oh, thanks. That's what I was looking for. Yeah, so I think we baselined on, what we agree on for artificial intelligence, right? And maybe a lot of you are like, way beyond that, right? Maybe you're already doing classwork with AI, maybe you're taking NLP classes, right? Maybe you're doing some projects on your own, whatever that is. But I think there's this tendency sometimes in AI to focus on just like what's the newest thing, right? Which is not bad, it's fun, it's exciting, why not work on cool stuff, right? But it's also important to understand what is actually the kind of domain of AI in terms of, okay, if I want to work in AI, these are the kinds of, domains that I could possibly work in. So, first we've got, natural language processing, that's all about, okay, how can machines learn, generate, process text all by themselves, right? So that's things like, your phone, autocomplete, right? That's very basic. We've got things like voice to text. We have so many things like machine translate. So, I mean, Spanish homework, Google Translate, I mean, right? So a lot of natural language processing has been integrated directly into our daily lives, right? The second thing is computer vision. So how can machines understand images? How do they automatically process and generate insights from them? So this can be things, especially in Arizona, right? We have a lot of autonomous cars. So we have good weather for testing. So we see a lot of the computer vision going on literally right outside here, right? Some of the other things, like we talked about, I think Professor Gupta also mentioned things like, image screening, medical image screening. Can we detect the cancer? Can we do these things on a more automated fashion? Those are all really in the realm of computer vision. Then we've got, data mining, right? And data mining is more sort of, in that traditional data mining sphere. And it's more about, predictive analyses. Can we find different patterns in the data? And that's, that's really been around for a while, and it's across multiple different industries, right? So let's say maybe you're doing like retail and you're understanding, okay, how do my customers move? What are the customer patterns, right? Things like that. Or, it could even be like, okay, social media, how are the users actually interacting with the platform? In general, there are many, many applications of data mining across multiple broad industries. Okay, the next one is optimization, right? And optimization, okay, that's pretty much a field of its own, right? But at its base, for example, in supply chain, right? It's all about taking, okay, what if I have multiple things that I need to do, multiple project deadlines, I have limited resources, specific constraints. How do I allocate all the resources in the way that they need to be so that I hit all of my project schedules on time, right? That's all about what optimization is. And the last one is anomaly detection, right? How do you find those irregular patterns? So this obviously is used in very many applications. One of the ones that it's used a lot in is in credit card fraud, right? So if I make a purchase and it's outside of my normal activities and it gets flagged, that's done through anomaly detection, right? Or sometimes cybersecurity. So a lot of times, things like intrusion detection, those are all things that are done by anomaly detection. So you can kind of see how the whole broad range of the world of AI can be quite different, right? So you might be working in these silos and never even touch, right? Because now we talk a lot about generative AI, which don't get me wrong, that's quite fun, and it can be applied to many of these domains, right? But it's important to know, if you're thinking about having a career in the industry, what the actual, broad parameters of what that career could actually look like. Yeah, so now that we've got that kind of down in terms of domains, the other thing I want to talk to you a little bit about is the different kinds of roles that you can go for in terms of, an AI professional, right? And they're all a little bit similar, all a little bit different. So the first one, machine learning engineer, right? So maybe you are more involved with training data sets. Maybe you're more involved with training models, right? Maybe you're doing those unsupervised, supervised learning techniques. Then you've got your AI engineer. So maybe you're more involved with things like neural networks, you're training those kinds of models. Then you've got data scientists. So data scientist is also one that's kind of like a very popular broad job title. So you could be doing a lot of things, but a lot of times data scientists tend to have a lot more statistical backgrounds and strong statistical approaches to how they manipulate the data and understand the data. Or you could be on the data analyst side, right? So the data analyst side, yeah, they do similar things in terms of, predictive analyses, but they're a lot more on also the business side in terms of maybe they're doing things like data visualization, maybe they're, building dashboards, things like that. And lastly, we've got analytics engineer, which is what I actually do, right? And it's sort of a newer job title. That's it's a new job title. It's not a new role, really. And all it is basically how we can transform, how we can optimize our data pipelines such that they are ready for analysis, ready for downstream data science tasks, right? And there's a lot of things that go into that. And it's not just, AI doesn't mean that if you're working on data, you're not doing AI. If you're working on machine learning, okay, yeah, sure, you're doing AI. But the goal of kind of going over this is to give you guys a perspective of what an AI career or working in AI actually can be quite broad, right? And the other thing really is that, these titles, they're just all titles to a certain extent, right? If you get into your first internship, you get into your first role at your first company, there are some tasks that you could do on any of these roles, right? And it's a lot about figuring out, okay, what are the expectations in this particular organization? How are the roles delineated, right? That's all what you have to kind of think about going into an industry position. Yeah, and so I think with that context in mind, right, the reality of the AI job, right, like I mentioned, this can be quite broad, right? So it's important to understand, like, if you go into industry, what would that actually look like, right? So this Venn diagram I've put together is kind of generally putting through different domains, right? So we've got the data scientists doing sort of all the, the AI data scientist kind of things. Then we've got software analytics, data engineers doing all the, data engineering focused tasks. And then I've got business at the top, right? In terms of, actual business impact and what the solution is, right? And you notice it's a Venn diagram because it really is a Venn diagram, right? In order to be successful at any one of these roles in a real industry profession, you need to have a little bit of each, right? It's important to understand how your data works, right? So if you're a data scientist, maybe you are doing some of that data manipulation yourself, right? If you don't have a big team, if you don't have a separate data team, maybe you're in a startup, you will be doing some of that yourself, right? If you're an analytics engineer like me, right? I build pipelines that work and interact daily with different kinds of models, whether that's LLMs or something else, right? I need to be able to understand how the models work in order to efficiently design and optimize the pipelines that I build to work well with them. And then of course the business, right? And I think for both of these technical roles, really the business and clearly understanding how to interact with the business is pretty much crucial, right? Because as a data engineer, a lot of my job, or really analytics engineer, they're kind of all the same, right, in the sense of that. But a lot of my job requires me talking to the business stakeholders, understanding what their needs are, understanding how to take what their project requirements are and turn them into a project and figure out what data that we need it is to actually transform that into the solution that they are asking for, right? And even from the data scientist side, right? If you build the best model, you build the most accurate model, the best there ever was, that can really only unfortunately take you so far, right? Because the way that we see, all of our impact on these projects, right, is that the business has to use it, the business has to understand it, and they have to be confident and trust your solution, right? If you don't have that, and even if your model is great, then unfortunately your project's probably dead in the water, right? It would be nice, but the reality is all of our work, whether it's analytics engineer, data scientist, however you want to call it, right? Any of that impact on the stuff that we work on daily is realized through actual business impact or actual business or value, right? So that is always important to keep in mind. Okay. So now that I've talked a lot about, general what analytics careers might look like, maybe let's take a segue and start talking about what it actually looks like at my job, right? So again, I am an analytics engineer in the Intel Global Supply Chain org, right? And recent technology spotlight, right? Everyone's thinking about it. Everyone wants to do it. LLMs. And LLMs, basically, for any of you who are not familiar, and generative AI as a whole, really, is a branch of deep learning that focuses on taking the transformer type neural network and extending that. So you can think of transformers as kind of probabilistic models that are maybe predicting like the next couple words in a sequence. I mean, this is quite simplistic, right? I'm sure a lot of you in your own NLP classes are doing more, right? But LLMs take this whole approach to a next level, right? It's not just the next couple words, it's the next couple sentences, it's the next couple paragraphs, et cetera, et cetera. And these models, right, are trained with billions of parameters. They're trained in terabytes and terabytes of data, and they're taking months to train. So what we end up with is that these foundational models are able to be used for a wide variety of applications. And this is really where you see the GPT-4, the Llama 3, right? That is actually what you're interacting with when you are talking to Chat GPT, right? And so on the right here, you can see a quick simplified diagram of how an LLM can work, right? So if you're just chatting with ChatGPT, right, obviously the LLM has its own pre-trained data set that's gone into it. Maybe you ask it a question or, it's called prompt specifically, and then it gives you an answer, right? And that's pretty much the simplest way that the LLM can work. But let's take a look at this diagram just a little bit more in depth, right? So let's say I'm a business user and I want to use an LLM for this. And let's say I'm using maybe Chat GPT, or let's say I'm using GPT-4 rather, right? So if I just want to do something that's like general knowledge, maybe that's fine, right? I think, GPT-4 has been trained to like 2023 something, and that might be okay. But then you might ask, okay, well, what if I want to know about something that is only in 2024? Or what if I want to know something that it's not possible for the LLM to know about, right? A lot of things that a lot of the tasks that LLMs are good at is taking large chunks of data or taking snippets of text and telling you insights, telling you inferences from it without you actually having to read it yourself, right? That's the whole point of the LLM, to understand language. So what if you want to use it on a business use case, right? How do you actually do that when it's not possible for the LLM to ever know that information, right? I mean, you're hoping that the LLM has not been trained on your proprietary company documents, right? So, there's an aspect of this is not enough in terms of the LLM architecture. And LLMs themselves, they're not deterministic in that they might guess, right? If they don't know an answer, they might give you their best knowledge, and they might even be confident about it, and they might just say, oh yeah, that's the answer, when 100% they are hallucinating and they don't know, right? So there's a whole side of it in terms of, okay, as the user, how much should I actually trust this information? And that really comes into play, especially when it's in a business context and you're trying to make data-driven decisions based on that business context. And so, one of the things that you can think, all right, if I need to give it more data, the most naive way is, what if I just pass it in as a prompt, right? So maybe I say, okay, I have this particular business document, maybe it's a contract, whatever it is. Here's my question, here's the following text, answer the question, right? And that will work, right? That will work, especially if you're asking like smaller text, and it's not too bad. But there's a couple of things to consider, right? First of all, LLMs have a context window, right? So I mean, this is a really bad simplification, but it's sort of like your work. Second, turn this off. Okay. It's sort of like your working memory, right? In the sense of if I give you a really, really long text, you can't really keep track of everything that I've said to you. And if I ask you to make decisions on it, if I ask you questions on it, it's similar thing. You might get confused. The longer your texts are in your input string, in your input prompts, the more the LLM is likely to be less accurate, the more it's likely to hallucinate, right? So, that might work in some cases, but this is not enough for what we might want to do, right? Um, and moreover, if you're thinking about LLMs in a business context, right, it's okay if you just want to get an answer on maybe a couple of documents at a time, maybe one or two long documents, you can proofread it, however, right? But it's expensive to pass in large amounts of documents, right? If I don't want to work on only one document, I have, maybe 500, 5,000 documents to audit. How do I design the LLM solution in a way that is actually business feasible, right? Because the technology could be there, but it doesn't matter if it's too expensive to use it. It doesn't have any impact in terms of like an actual business value. So to solve that problem, we need to understand a little bit more about how LLMs work underneath the hood. And this is where we're going to talk about word embeddings. So basically, looking at the left, right? Word embeddings are basically a mathematical vectorized representation of text. So I think, maybe a lot of you are familiar with this already, but fundamentally, the model does not understand text, right? You have to convert the text, the words, whatever, to some sort of mathematical representation. And of course, there's multiple ways to do this. You might say, okay, well, let's just give it a try and let's assign a random numerical value to each of these, right? And so I could say, okay, so the apple is this, the orange is this, the mushroom is something else, right? And that could work. Each of them has a unique value, so they're all represented equally in the model. But if you think about it from an actual language perspective, right? You and I both know that an orange is a lot more similar to an apple because they're both fruits, right? And they're both a little bit farther away from the mushroom, right? Simple basics. So if we do it that way, then the model is not actually fully getting that context and that encoding that we want it to have when it thinks about the words. So instead, a better way to do this is through using our neural networks and backpropagation, we actually create the encodings in such a way that the semantically similar words have similar vectors, meaning that the distance between the vectors is smaller. So obviously you can see right here, right? Doesn't take rocket science. The red apple, green apple closer together, and both of the orange and the apples are farther than the mushroom. And it's really this sort of proper mathematical vectorized embedding that allows the LLM to do its higher order reasoning, right? So basically, we can take this concept and think, okay, if I want to pass in new data, like going back to my business use case, right? If the LLM doesn't know, right, what I can do is I can take my previous data, vectorize it, embed it, and put it into a vector database. And that then becomes the knowledge base for my LLM. So now that we've decided to vectorize our fancy new business document, your next question might be on how do we actually best do that, right? And okay, for analyzing the document, you could just say, okay, vectorize the whole thing, right? And then return me back the whole thing. Well, that doesn't really solve a problem, right? Because the whole thing was we didn't want large chunks going into the LLM. So we have to get a little bit more thoughtful about how we want to process and store the document before it gets to the vector database. And we do that through a process called chunking. And chunking itself is pretty simple, right? It's just the concept of how do we take large amounts of text and break it down in a way such that we can then, vectorize them individually, like you see there, and then store them into the vector database. And there's multiple ways to do this, right? There's some pretty naive ways to do this in the sense of, okay, let's say I just have like, I don't know, 50 character token limit, right? That's simple. But or maybe I do something like recursive text splitting. So on every single new line, I split my characters or something like that. Or you can get a little bit fancier and do things like semantic chunking. So that means that, long text, if we have sentences that have similar ideas, they are grouped together in the same chunk, right? And that could be even better for us. And I think, here your next question might be, okay, I chunked the document. There's different ways how to do this. But it's really the question of like, why do I care, how you do the chunking? What does the chunking quality matter, right? And, beyond the idea of not looking at the whole document, right? The LLM interacts with these chunks through the vector database, and it's through this vector search, right? So when the quality of the chunks is semantically higher, that means that the actual quality of the vector embeddings for that chunk is closer to the actual meaning of that in the text, which means that your vectors and your chunks are better representing the ideas that originally you wanted to pull from the document in the first place. So the quality of the chunks can often have quite a significant impact on the resultant LLM tasks that you want to do. Sometimes it doesn't, and you can get away with just doing, simple recursive text splitting or things like that. And sometimes it does. So it's one of the things that you have to tune and play with. And I think in general, that's sort of like the MO of LLMs and, generative AI, right? And, AI as a whole, in that there's not going to be like one right answer for how you should chunk. There's not going to be one right answer on how you should, store your vector database, how you should index your database, how you should perform that search. There might be good ideas for one particular use case, and that might not be applicable to your next use case. So, I think it's, in terms of this discussion, it's enough to kind of get an understanding of what the general architecture looks like, but it is something to keep in mind that for your own use cases, if you're thinking of playing around with it, it's probably something to tune. And yeah, so let's put that all together. And I think we've arrived at RAG, right? And I think maybe you guys have heard of this, but it's retrieval augmented generation, right? And it's this whole process of what we've just talked about, from doing the chunks, from vectorizing the document and putting it back into the LLM. So you can see all the way on the left, we've got the documents, we chunk it however it needs to be, then we embed it, and then we store it in our vector database. So then, once we want to ask the LLM on questions on our new data set, we basically do the same thing with the question or the prompt, right? So we embed the prompt and then we search for the chunks that are more semantically close, right? And that means that the LLM can retrieve the chunks that actually specifically have the information that we might be looking for in the prompt. And that way, we are basically getting a much higher quality result, and we don't actually need to look at the whole document with this RAG pipeline. Okay, so I think, we've kind of gone through the basics of the, the general LLM RAG pipeline, so everyone's on the same page. This is one of the ways that we actually use it in reality, right? How do we actually implement this in industry in one of the projects that we work on? So on the left here, you can see it's describing a manual contract auditing process. So okay, I'm a lawyer. I need to audit contracts. What do I do, right? I go through and I'm looking for specific contracts. I go to the database. Maybe I pull them out. I maybe have a list of audit questions that I need to ask on the contracts. Then I go through, I review the whole contract. I make some decisions on it. I score the contract. and finally it gets on that contract dashboard, right? That is a manual process, and it can take days to weeks to get that done, right? Because this is probably not the only task that the lawyer is working on. So this is a prime candidate for an LLM automation project, right? And so you can see that's exactly what we did, right? So on the right, you can see that basically we do the same steps. So we get the contract, we start processing it, we chunk it, and then it gets sent to the retrieval. So it gets sent to the vector database. We have our audit questions that we want to ask on it. We pull back the relevant chunks. Then we have, specific more audit question answering prompts. And then we return the audit answers and the reason as to why we said those answers, right? And this process actually basically shaves down the contract auditing time from months to minutes, right? Because if you're going to do all of your contracts, that's just not one contract. If one contract takes weeks, right? Then think about how much more you're going to be able to do, not just one contract, but maybe 500 contracts, right? So basically also it means that you're freeing up your time, your employees' time, right? So from $400 to $10, I don't think that's a bad change. So but yeah, so I'm using this example because this is, obviously we're doing this right now, but it's also a good example of use cases that are good for LLMs in the sense of at least from a business perspective, right? Are there things that are already being done, but they're being done at a smaller scale, right? Or they're being done, kind of manually. You don't have the ability to do more of it. This is a perfect case of how you can take an existing business process of something is valuable and turn it into something that is automated and basically can magnify the value that you're getting from the solution. Yeah, so I think with all that said, and I'm bringing us back to this slide in terms of analytics teams, because I really think it's important, right? If you're thinking about working as an AI professional and getting into industry, the pretty much number one thing I think is your impact and your business value, right? I think I did mention it before, right? Because when you're thinking about projects to work on, is it something that the business actually needs? Is it something that they're already doing, right? Like the manual contracts, for example. Is it something that helps a whole organization? Is it something that, okay, I implement this new feature and hundreds of users are going to use it, right? Or is it just one person's job, right? Or is it just a couple people's job? It's important to understand how the things that you work on are tied to real impact, right? Because time is precious and you don't always get to work on things, all the things that you want to work on. And it's really when you have that clear business understanding and that clear business sponsorship that you actually see what the things you work on transformed and created into something real. The second thing is achievability, right? So oftentimes, you might have a really great idea, which is definitely good. But again, thinking about things in the business context, is this actually an achievable solution? Is the business ready to accept it, right? If the solution is there, are there enough people that are going to adopt it? Is it enough in the sense of, okay, I want to do this cool new thing, but how do I kind of balance that with the fact of, okay, these are the operational things that the business values and impacts. So I think overall, maybe these are some of the things that as someone who's not yet in their internship or not yet in their not in their full-time roles, maybe this is something a little bit future for you to think on. But the overarching idea, right, is the idea of like communication, right? Because whatever project you're working on, if that's a portfolio project, if that's something you're doing just for fun, if that's something you're doing classwork, maybe your first internship or, your many year internships, whatever. If you can't communicate clearly to your business people, to whoever your audience is, that this is what this is how it can help you, and this is why you should use it, that's it, right? It's hard to realize value if you're not able to clearly articulate that value. And really analytics teams that kind of focus on making sure that all of these things are met. I mean, among other things, but it's analytics teams that focus on all of these things that are actually valued and, you know, basically supported by their organization. Yeah, so this is my last slide. Again, I think, you know, all of you are here because obviously you want to get involved with AI, which is great, right? You're already doing the first thing. But I think I will say more than anything else, you know, start now. So I'm sure some of you already have, right? But I think now more than ever, we have so many things online that we can learn. We have so many things of like, you know, personal projects that you can work on. There's so many tutorials out there. And more than ever, try to get hands-on experience, right? Classwork is great. So, you know, maybe you are doing interesting work in your classes that you can talk about and whatnot. But I think more than anything else, real world projects really do matter, right? Because to be honest, like manufactured data sets, you can definitely learn from them. Like, you know, Iris data sets, yeah, great. I did that project too. But the thing is that when you actually work on real world data, you end up learning a lot more. So I would encourage you to find a project that you personally care about, maybe something you personally want. Maybe it's a feature that you would like to have in your own life, right? And just start working on it. And I think, you know, that kind of passion, that I think is translated in people you talk to or about your projects. And lastly, be curious. Don't be afraid to ask questions. I think this one's obvious, but at the same time, it's like not obvious at the same time, right? Because I think as, you know, younger professional, as an intern, I had to kind of learn this the hard way, right? In the sense of you might think like, oh, they're gonna think I'm stupid, but okay, imagine how stupid you'll feel when it's like 2 days later and you still don't know the answer, right? But you know, more than that, right? It's not just the hesitation. If you're curious about something, let's say you're an internship and you know you see a project that you want to work on that's like kind of adjacent to what you like, ask about it, you know. If you see something else that your another team is working on and you find that interesting, ask them, hey, can I have a conversation about what your team is doing, right? People will surprise you and they will be really supportive of you, but you just can't find those people if you just don't ask them, right? And I think especially as a younger professional, that's the one thing that even I could have done more, right? And that's the one thing I see people joining our team now, that people who do that, they learn and they grow so much faster. So yeah, I would encourage you all to do that. And I think that is it. The floor is open for Q&A, so please. Oh.
I wanted to ask that, like you mentioned the word vector model. So how would you decide like how many dimensions you need for that vector, and how would you like, sorry, like how will you decide how many dimensions should be in that vector, and how would you like allot the values to those vectors?
Yeah.
Because it's not possible to do it manually, right?
Right. So, I mean, you can train your own vector embeddings. I've actually never done that. So, OpenAI, they have their own embeddings models that they release. And if you're working on things like LLM applications, I would encourage you to use those particular embeddings models. So they would have done it through the whole like neural network backpropagation method, right? So they would be doing that on their side, but it's just it's available to you as like a black box model that you can use for embeddings. And there are many different embedding models out there. So if you want to try an experiment, definitely do that, right? But I think probably the performance that you'll get will be better with those, you know, out of the box models. But I mean, you're learning, so it's not a bad idea to experiment.
Um, uh, yeah. Hi. I just wanted to ask, do you think true AI is possible, artificial intelligence that does not need a database for making any assumptions or decisions?
You said group AI?
True AI.
True AI. Oh, I
Yeah.
see. Hmm. I don't know. I don't see it happening in the next few years. Let me put it that way, right? Because in terms of like, database, like even the things that we're doing right now in LLMs, right? So much of that is focused on like the example that I showed you right now, right? A lot of that is on optimizing vector search, right? Because your LLM can be amazing, right? But if you're not retrieving the right chunks, the right information from your database, then your solution could have subpar performance, right? So I think maybe that would be cool, but I don't see it happening like anytime soon. But I don't know, maybe you'll be the one. So
Hello. You mentioned different domains requiring different abilities, and
yeah,
let's say I want to become a data scientist, but I don't have a statistics background.
yeah.
Uh, do I have to go and get that, or can I get into the industry by with my using my other skills in business and programming?
Yeah. Well, so I'll be honest, there's nothing that you have to do in life, right? And I know that sounds very philosophical, but I really mean that because um, I know yours is a specific question, right? But for me, coming into industry, I really didn't have an idea of like how much you learn on the job, right? When I came into my job, like I thought I was just gonna do like basic data stuff, right? Because my background's computer science. I did some analytics stuff, but when I got to industry, when I started talking to different people and different groups around me, I saw how many people had switched from one career to another and just started learning on the job, right? Um, so I think part of my answer to you would be do not be limited by what you think you have, just start doing because practical experience is worth a lot more than study, right? But at the same time, to your point, yes, having a strong statistical background that will set you apart, right? Because there are some things, life is unfortunately competitive, right? And even for yourself, right? Even if those are statistical skills that you don't necessarily have when you start out, those are things that you should pick up, right? Because it's about how do you differentiate yourself in terms of building your brand and building your niche in terms of that role. So
Yeah, just a minute. So before we go for follow-ups, how many people have more questions? Okay, so we'll just try with the new people and yeah, come back for the follow-up.
All right, hello. Hey, I
Hello.
think you brought up a good point about learning how to build your brand and promote yourself. And I just wanted to ask, like, going back to the idea of project ideation, how did you, I guess, as you worked in the field, learn how to promote yourself to these businesses and clearly communicate your idea to them?
well, I don't know if this is the answer you'd like, but I found someone smarter than me who was already doing it and I copied them. I'm not even gonna lie, right? And this is how mentorship works basically, right? You surround yourself with people who are smarter than you, who have skills that you have, and you ask them how they do it. You ask them, hey, I saw you did this. I'd like to do this. Or if you do something wrong, maybe something doesn't go as well as you want, right? Then you go to your mentor, you go to your coworker, you go to that person that you trust, and you say, hey, I know you have an expertise in this. How would you suggest I proceed, right? And I didn't actually do this a lot when I came into like my first or second year. And I think that really held me back, right? Because it's again, it's like the whole idea of be curious. What you learn is so much more from other people than you think. Um, and beyond that, in terms of like how you want to do your own projects and like how you come up with ideas, you'll learn that. Like the more you start working, the more you understand your organization and like if you do internship, for example, you'll understand what the problems are, right? So that's what I would encourage you to do. Beyond learning from other people, I would really recommend you in any, I mean, if it's personal projects or internship or industry role, look around you and what are people really worrying about? What are the main issues for them, right? That is what you should be looking at when thinking of new project ideas.
All right, thank you.
Hi, good evening. So, as you had correctly mentioned that, hands-on is the best teacher kind of thing. So, I was approached earlier in my studies by a company who wanted to build something like an LLM for education based. But I had turned it down at that moment because I'm coming from a robotics background, not a highly computer science background. So now just a question to you, like which LLM would you prefer? Now there's Bard, BERT, Gemini, ChatGPT, but to do a collab with or like to take up API and GitHub material from, which
Yeah.
LLM would be the best to do a cross with?
Well, I think probably if you ask different people this, you'll get different answers. For me personally, I will say that I have worked most with, the GPT-4, GPT-4o, GPT-4o Vision, right?
Mhm.
Like the open AI. But I have, read kind of news in terms of, okay, I've heard Llama 3 is pretty good, so you might want to try that.
Okay.
I've also worked some with like on-prem LLM models. So for example, if you're not willing to send your proprietary information to, Azure or cloud or Microsoft or whatever, right? So I would say that for your purposes, probably just start with whatever's easiest, right? Because you're learning, right?
Right.
But beyond that, once you start working with the models, once you start seeing what the difference is and what certain models are good at versus others, that's how you learn on which you prefer for which tasks.
And which which LLM is the easiest to deal with? I know it's not easiest because all of them are on the same basis, but yeah.
Well, I don't know that there's one that's really easier to deal with than the other. Maybe if some of you have actually experimented more than I have, you could have an answer to that question. But I will say, when you have things like LangChain, that are kind of like LLM orchestration frameworks, a lot of like what model you're using is kind of abstracted out as like almost a parameter. So there are of course things that you learn model to model, right? But I don't think it necessarily should be a question of what's easiest or what's most difficult. I think it's all pretty similar. Think about the application that you want to use and start experimenting.
Cool. Thank you.
Okay, so we will take two more questions. Okay, you and you.
Hi, I wanted to ask, like, you mentioned the chunks that are made in the document.
Mhm.
Might be the answer might have been already said, but like, how are the chunks made? Like, is there some format that's followed, or it's
Yeah.
randomized thing?
Yeah,
And
so there's actually different methods that you can do for chunking, right? And that's what I was talking about in terms of chunking quality. So there's some methods like the most simple method, right, would be to cut it off after a certain amount of tokens, right? So a certain amount of characters, whatever. You could do things like recursive text splitting, right? So like I mentioned, okay, cut it on like new line or something like that. The other things that you can do are things like semantic chunking. So that's actually what we use the most in our pipelines. So that actually requires well, it's kind of like a homegrown algorithm, but there's many different ways that you do semantic chunking, right? But we actually look at the document format, then we actually use a prompt that looks at the different chunks and chunks them and splits them at different places in the document. So I will say that there's a lot of different chunking strategies out there, and this is pretty much a field that's changing right now, right? So I would just Google basically. And actually, for example, like I was talking about LangChain earlier, right? A lot of these like kind of orchestration frameworks, people are actually putting the chunking algorithms out there so that you can, download and experiment with them. So I would encourage you to look at open source ones, and that would probably, start some ideas, and then you can go from there.
I just wanted to know your views. Do you think that a Turing test is enough to check whether it's AI or not?
Um, no, personally, because I feel like consciousness is something separate. But I mean, personally, for me, this is more of like a fun to debate rather than like has an actual answer. So if you think differently, hey, I don't think you're wrong either. So that's what I would say. Yeah. Yeah. Right. Yeah. No, I mean, it's an interesting thing. I mean, I haven't played around with this too much, but some people say some people say, and I've tried it a little bit, but if you're more polite to your LLM, sometimes you'll get better answers, right? So, um, um, yeah. So I don't know. It's a fun question to debate, don't get me wrong, but I don't think there's a right answer to that question. I think we're done then?
Yeah, so okay, that was loud. Just one last question we would like to ask as an organization to you. First of all, we really appreciate the time you have given to us. It was a really great talk, and I'm pretty sure a lot of people, the doubts they asked, helped them clarify what they had in mind. Just one last question from our side. There are a lot of freshmen and sophomores out here.
Mhm.
How many of you are freshmen? Show with a raise of hands.
Wow.
And sophomores? So one question which we also as AI Society constantly get is,
Yeah.
we are a computer science major, we are a robotics major, we are a data science major.
Mm.
We know AI is all the hype, but then how do we get into it? Where do we start? So, you know, if you were to tell two main tips that, okay, today go home and then this is what you do for the next 1 year, and that could sort of be an entryway into AI for you, what would
Yeah.
it be?
Well, I think I've kind of shared it maybe already in the sense of like my last slide, right? Start now, right? Build your portfolio, do things actually, right? Because the more that people see what you've actually worked on, the more you can communicate that out, right? Whether that's, you know, maybe you get involved in undergraduate research, right? That's a great one. That's how I started actually. So I think more than anything, it's important not to be just bogged down by your classwork. You just have to try something outside of class, right? Um, Other than that, I think it's kind of another thing that I've already said in my presentation in the sense of communication, right? This is something that, you know, you kind of don't really pick up until you're in business for a while, or maybe you're smart and you do, but soft skills matter, right? And I did talk about it in terms of like business communication and whatnot, but it's more than just being able to just or clearly articulate your ideas, right? Sometimes technical skills can be taught, right? But soft skills are harder, right? Because sometimes people have, you know, they're more aware of what they should be, right? And these are the kinds of things that can make a difference between deciding between candidates, for example, right? So, again, things that I said in my presentation, but you know, start now and work on communication. That's what I would say.
Cool. Thank you very much for your time. Okay, guys, so now me and Pooja will quickly take 5 to 10 more minutes, and we would like to brief you up about the activities AI Society will be doing in the coming semester. So hope you're excited for them. But yeah, these are our three upcoming events, or the sort of big event sort of a thing. First, we'll be having a mountain hike that will be in collaboration with ISSC. The basic premise of this idea is, you know, you all are interested in AI, but then there are hackathons where you need to form teams. There's so much, you know, you want someone to talk to. You have a question in class, and maybe another person has the same question in class, but then where do you interact with them? This is a sort of new age approach to a networking activity where you can meet together, chill together. Hopefully there'll be food, fingers crossed. There'll be drinks. We are in talks for sponsorship with Prime and Alani, so hopefully there'll be drinks, there'll be food, and there'll be a lot of fun. This will be followed by an AI game night that will be in collaboration with Tuka peer mentors. How many of you are in Tuka? All the freshmen here. Oh, cool. So that's again a sort of networking event. This is incidentally going to be in fourth week of October, just around the time of midterms. Hopefully that should be a stress buster for you guys. And we'll be ending the semester on 23rd, 24th November with a hackathon plus panel discussion. How many of you are excited for a hackathon? How many of you have already taken part in hackathons before? Oh, that's cool. So yeah, that's pretty much it. That's the events we are going to be doing. Now I'll hand it over to Pooja to talk about our weekly workshops where we actually teach AI concepts to you guys. Over to you.
Hi guys, I'm Pooja. I'm the technical vice president here. So we have two main labs. One is the ML lab, and the second one is the NLP lab. Like we know, we just want to get started on things that actually make sense and it's real world. Okay, so that's why we came up with these problem statements. The ML lab focuses on building a Sun Devil Sync recommender system. Well, there are a lot of events on Sun Devil Sings, and we just confused as to what to attend to. So this recommendation system basically gives you an idea of what are the events that you would probably like. So we will be building it from scratch. We'll start with data pre-process. Okay, I'll get into the details in the next slide. Moving on to the NLP lab, we will be building our own GPT. Sorry. Yeah. Is this fine? Yeah, is this fine? Yeah. We will be building our own GPT. Again, I'll get into the details in the next slide. So, what are we trying to achieve through the workshops? First thing is we break it down to the basics so that anyone can join and have fun. So, even if you're a freshman or a person who's already into AI, you will still enjoy this. And we will have real life skills. Like I said, these are some things that's hot topics right now, and we're gonna like collaborate and interact and have fun along the way. So the most important thing is the stuff that you learn as a part of the project uh, are really important as a part of your AI career, right? So you'll get your resume ready projects and skills. Like you will literally learn everything associated with it. And the most important thing of all is we'll be doing it hands on. You'll be coding along with us, and we're going to start from scratch and complete it throughout. And this is the perfect for beginners and people, like I said, who are into AI, because we'll start with basics, but it's going to get really complex towards the end. So it's going to be a series of 8 weeks, if I'm not wrong, and we'll go through it together. So moving on. Yeah. So this is what the ML lab is going to look like. We'll start with data cleaning, handling, and pre-processing, and then we'll get into feature selection and feature engineering, and then we get into supervised and unsupervised learning, and then get into dimensionality reduction, and the last one will be recommendation system. So you'll be introduced to models, metrics, and everything associated with the specific topics in the coming weeks. And the NLP lab, we'll start with the basic text speed processing and bag of word models. And then we get into n-grams and TF-IDF. And then we'll get into proper text classification with word embeddings, something similar to what Sagarika had mentioned today. We'll get into the architectures like word-to-vec and glove. And then we get into the neural networks like RNNs, LSTMs, and stuff. And then we get into the state of the art model, which are the transformers. And we'll talk about the attention mechanism and stuff. And the last part would be understanding GPT and BERT, like basic transformer architecture. And then we'll end it with some fun prompt engineering techniques, and we'll build some, with the help of APIs, we'll build some cool projects towards the end. So another thing is if you attend all these workshops and do your projects, this will help you with your hackathons if you're completely new, and you'll also like I think we'll be giving a certificate of completion for the projects as well. Yeah, so that's basically it. We want to support you and encourage you to build projects. And this is a new club. Like I think this is our third semester, and we are still exploring the different ways to benefit, like help you benefit from the club. And these are some things that we'll be doing. Like I said, we'll have the skills and knowledge. We'll have project completion certification. We'll have preparation for research stuff, and we'll also like participate in hackathons as a team. I'll get into that in the next slide. So the first and the most exciting thing is we are looking for research opportunities. Most of you all don't know like where to start with respect to research. We have people in the club who are already actively researching in the fields right now. And we're also in talks with professors to get some collaboration to volunteer in their labs. And yeah, you can like get into research through that. So other than that, we have internal teams within the club where you can form your own team and come up with a problem statement or a research statement, and we will guide you through with. We have professors as advisors. We have some masters students here as well. So that is another thing. And next thing is we will be forming a lot of hackathon teams, collaborating with other clubs at ASU. We are in talks with a couple of clubs, and we'll create hackathon teams and participate in different hackathons in and around US. And yeah, that's basically what it's cooking right now, and we're so excited to have the semester going, and we're also open to suggestions. Whatever you want to add, you want to have as a part of the club, we are we're in lookout for that as well. So I think that's it. If you have any questions, you can reach out to me. Handing over the mic to.
Yeah, and last of all, these are our social media platforms. That's where we'll be posting like all of our events or weekly workshops. And actually, we have our workshops tomorrow. So if you guys want to join and start the semester with like a bang, so definitely come. But yeah, so if you have any questions after this, also you guys can come up and talk to us. And if you have if you think that you want to like volunteer or even like participate in our club, we are looking for like officers also. So just come talk to us if you're interested. So yeah, thank you so much, guys.